Out of the different material types, the one we haven't played around with as much is unique flexible filaments. Sure, we've seen a few different shore hardnesses and more recently a high flow variant, but outside of foaming TPU, it's been a slower area to develop. This is why I was really excited when BIQU reached out letting me know they were releasing a new flexible filament called Morflex. The standout feature for this material is that on the spool it is 90A shore hardness, but after printing it, the resulting material is in 75A. In the time I've been 3D printing, the most difficult aspect of flexible filaments has been consistent extrusion. Once you get below a certain hardness, the filament strand just becomes like a wet noodle and causes all sorts of nasty clogs. Sure, hardware has absolutely gotten better, which is incredibly helpful, but it still has its limitations. BIQU sent over a spool of this Morflex material, and in this video, we are going to have some fun testing it out. We'll go over the material specs, what the printing requirements are, and of course, we'll do some printing. So with all that being said, and without further ado, let's get right into today's video. Let's start by taking a look at the material and its properties. So what is Morflex? Well, that's a great question, and the product page, outside of some basic specifications and marketing on using it to print footwear, doesn't tell you much. I requested a copy of the materials TDS in hopes of getting some additional information, but I see no mention of whether this material is based on a TPU, a TPE, or something else entirely. I did find it interesting that Morflex is apparently patented. The TDS in general is pretty bare bones, and the main things it includes are some printing parameters along with mechanical properties. One thing I really like doing is comparing the TDS of a specialty material to one of a maybe more similar yet standard material, but in this case, BIQU doesn't make just a standard TPU or flexible filament, and the other two TDSs I pulled, one being from Tech and one being from Polymaker, both use different testing methods. I'm not aware of any formula that would let me convert the testing methods so I can get a true apples to apples comparison, but if there is one, I will leave the data points on screen for the different mechanical properties, and I would love to know how these different filaments stack up against each other.
Thank you to PCBWay for sponsoring today's video. With over a decade of experience, PCBWay provides reliable, high-quality PCB prototyping and fabrication with super fast turnaround times. In addition to PCBs, they offer CNC machining, 3D printing, sheet metal fabrication, and injection molding services. I recently used their SLM printing for a 3D printed toolhead, and the results were fantastic. Whether your project is big or small, PCBWay has you covered with order quantities from 5 to 10,000 boards. Use the link in the description to get a $5 credit towards your first order today.
With that, let's move on to the printing requirements for this filament. Luckily, the parameters are really the same as just a standard 95 to 90A TPU, so if you've printed with any of those before, you should have no issues with Morflex. The temperature range for the hot end is between 225 and 260 Celsius. This is a pretty large range, and my default in a case like this is to go with sort of somewhere in the middle. I ended up settling on 240 Celsius. For the bed, the recommended range is between 40 and 60 C. After printing with this material and seeing how ridiculously well it sticks, I highly recommend starting on the lower end of that range. I printed with powder-coated PEI, which is known to stick very hard with TPU, and I very likely should have put down a layer of glue stick to help act as a release agent once the part had finished printing. For the flow rate, BIQU recommends a slow 2.8 to 4 cubic millimeters per second with a 0.4 nozzle, and 3.2 to 5 with a 0.6. Just about all manufacturers set the speed or flow rates to a very conservative value because they're trying to make it as compatible with a wide range of hardware. And I recommend sticking with those slow values, at least at the beginning. I say this in just about every material testing video, but once you have had some successes with the sort of slow default parameters, then you can scale up from there and see how quick you can push the material. There is zero mention of cooling, and if the piece you're printing happens to have no real bridges or overhangs, maybe you can get away with no cooling, but Otherwise, my recommendation is to start somewhere around 20 to 30% layer cooling speed. With any flexible filament I've previously printed, I always start off with drying, and BIQU recommends drying for 3 to 5 hours at 65 Celsius. Drying out your filament, especially when it's a specialty filament, is going to be really good practice to remove the uphill battle that moisture can be, which would lead to really poor quality prints even if all of your settings are dialed in perfectly. In my case, I put the spool inside of my poly dryer on the second heat setting and I just left it to dry out overnight. For printing, I'm using my Bambu Lab H2D. I've been testing out this printer over the past few months, and while I've thrown a lot of materials at it, the one that I haven't done is any form of a flexible filament. Funny enough, on the bottom of the Morflex page, there are some recommended parameters for your spool holder with a section dedicated specifically to the H2D. BIQU recommends using a spool holder with bearings to minimize any possible drag that could occur as the extruder is feeding the filament. While I don't think that's a bad idea, and I actually have a few external spool holders using little 608 bearings, my recommendation is whatever design or bearings you go with, that it is not too loose. If the extruder is able to pull it and the spool just sort of keeps going, then your filament will pop off the side of the spool and you will get a tangle. So it's kind of a balancing act of not having drag, but also not creating tangles by having a spool holder that's just too loose. For the H2D specifically, there are some considerations when printing flexible filament. For starters, outside of Bambu Lab's TPU for AMS, you don't want to use any flexible materials in the AMS or you will get a clog. You need to feed the filament directly from an external spool holder into the tool head. On my X1 Carbon, when I've printed with flexible filaments, I just use the built-in external spool holder that comes with the printer, but because BIQU had some specific recommendations on the spool holder for Morflex and the H2D just being a bigger machine with more distance that the filament would have to travel through into the tool head, I wanted to look at what other options existed. So I went over to MakerWorld and searched for external spool holder solutions for the H2D, and boy were there a lot of them. I ended up finding a top-mounted one that I really liked the design of, but it required a fair bit of printing and I felt that it might just be overkill. I still think that's likely the case, but after finding an article from Bambu Lab on printing with TPU on the H2D and them linking to this exact spool holding setup, I decided to just go forward with it and print it out. The model consists of two side pieces that snap onto the printer's frame and a large cross piece that runs between them, adding rigidity and holding it all together. On that center piece, there is a print-in-place sort of kickstand hinge that pops out and braces the spool holder up against the other side of the frame and really makes the whole thing nice and rigid. Cutting a few pieces of PTFE tubing, I've now got a very direct path from the spool holder into my tool head. Next was to figure out what to print. While a material like this can have many different applications, after spending so much time on the Morflex product page, I couldn't help but think that I needed to print out some footwear. I found a model for a pair of slip-ons called Airslides that looked perfect. There were a few different variants of this specific model, with one of them being positioned and set up specifically for the H2D. This had the model at a vertical 10-degree incline, and it also had built-in tree supports to help with keeping the thing from falling over as well as supporting the overhangs. I checked out the default printing parameters for TPU, anticipating I was going to have to tweak a couple of things, but they were spot on with what the recommendations are for Morflex, so I ended up just sticking with the default profile and sent off these slips to be printed. This was a fairly long print, with the largest bottleneck of the entire thing being, of course, that max flow rate, and in total it was approximately 2 full days. For the first half of the print, everything seemed to be going quite well, and the only things I noticed was stringing in the sort of padding or the gyroid mesh of the shoe, and then there was a couple sections on the bottom where it had a slightly steeper overhang where it looked like it definitely could have used a bit of additional cooling. Once we got about 60 to 70% of the way through, I began to have some concerns. The Z-hopping, along with the travel speed when it moved from one slipper to the other slipper, was causing the parts to vibrate a bit left and right. And this was causing some obvious ringing, which I'll get some close-up of. But my biggest concern was actually losing the entire print altogether by it maybe falling over. Because I was so far in, I ended up just letting the print complete and hope for the best. Well, the print completed successfully, and then came probably my biggest challenge of this entire thing, which was trying to figure out how to get the parts off of the build plate. On the first slipper, I just went with brute force, using a combination of flexing that build plate at extreme angles and pulling on it, and I ended up getting the shoe off, but I noticed that it left a tiny bit of the very tip, a couple of layers stuck on the build plate. So with the second slipper, I tried using just one of these little blade print removal tools to see if I could get underneath the base of the material. And that didn't work any better. That actually worked worse. And the print removal tool ended up cutting 5 or 6 layers off the top of it. So both methods, brute force and trying to use the print removal tool, were equally ineffective. With a lot of patience and peeling, I was able to get all of the material off, but this was absolutely a lesson learned for next time. This is by far the biggest and most complex flexible filament print I have ever done. A lot of the things I've done previously are much smaller and simpler, like maybe a phone case or some sort of gaskets, and overall I'm really pleased with how these turned out. The main things I would do differently if I were to print these again is to increase the cooling ever so slightly, and instead of having them vertical, I would have them laying on their sides, and even if that meant I had to use more tree supports, I think that that would help with a lot of the ringing I saw, since the ringing really didn't start until 60 or 70% through the print. Pushing on the slippers and bending them in different directions, it certainly feels soft. But with flexible filaments, the part geometry and infill has a massive impact on the stiffness, so this isn't much of a test. Because of this and my own general curiosity, I picked up a small handheld Hardness A durometer tester so that way I could get some measurements. I then printed out a 35mm cube at 100% infill using Morflex, another old 95A TPU I've had for years, and a third using Polymaker's Polyflex TPU90. This instrument uses a small spring-loaded pin to measure the material's resistance to indentation. With the 95A TPU, it measured between 93.5 to 95A. For the TPU90, between 88 and 89.5. And for Polyflex, between 83.5 to 85. This was quite a bit higher than the claimed 75A shore hardness, and this was on the top surface of the cube. So the next thing I did was turn the cubes on their side and run the probe again. The 95A TPU had a similar range of 92 to 94A. Same with Polyflex at 88 to 90. But Morflex dropped to 77 to 81, depending on the probe's location. I'm not entirely sure why Morflex specifically out of these 3 different materials had a lower value on the side, but the lower value on the side at least put it in range of the claimed softness from BIQU, which is 75A plus or minus 3A. There's still a handful of things I'd like to find out about this material. For starters, does the temperature you print at have any impact on the final material's hardness? The range was 225 to 260, but there was no mention or indication of what printing at those different temperatures could do as far as impacting, if any, the hardness of the finished part. And the second is, how fast can you reliably print this material? If it's 90A on the spool, so that's the hardness it's going into the extruder at, and it's coming out at somewhere between 78 to 81, I would think that you could probably push it quite a bit faster, especially if your printer has a very tight or closed path for filament feeding. And that's been Morflex. I hope that you enjoyed this video, and that if you had any questions about this filament, I was able to help answer them. After seeing these slippers that I made for my wife, my son has already requested a pair, so I know what I'll be doing next, but I'm quite curious how this material would do to just print something like insoles for an existing shoe. If you end up giving this material a try, please come back and let me know what your thoughts are, and I'd love to hear of any other applications that you can think of for this material. As always, if you have any questions, let me know in the comments and I will do my best to answer. And if I don't have the answer to your questions, I have no problem reaching out directly to BIQU to try to get those answers for you. On that note, don't forget to like and subscribe for more great videos. We make a video just about every single week, so there's always fresh content coming your way. If you want to support the channel further, I'll have links in the description over to our Patreon where there are some really awesome rewards. Huge thank you to all of our existing Patreon supporters. I appreciate each and every one of you for allowing me to come back every single week and spend more time doing what I love, which is making content for you all to enjoy. On that note, this has been Daniel from ModBot. I look forward to seeing you guys in my next video. Peace, guys.